Good afternoon, everyone. Sorry about all the technical delays. That thing just crashed. I don't know why. Uh, so, so welcome to this session on Sage. Sage is actually an open source mathematics computer software package. It's mainly aimed to be an alternative to the big M's, Mathematica, MATLAB, Maple. Sage is actually nothing but a collection of Python libraries with the power of Python programming language added to it. So that's really what attracted me to Sage, and that's how I just started checking it out. And I found out that Sage is really, really nice to use, very easy, primarily because it has the power of the Python programming language, and it provides you with an IPython shell. For those of you who haven't used it, it's an enhanced version of the Python shell with auto-completion, saving history, snippets, intelligent copy-paste, and so forth. So that's really why I started using Sage. I'm actually a graduate CS student back at my university, and I was a teaching assistant for the cryptography course. That's where I started checking Sage out, and now I'm using it extensively in my mathematics courses for the past 2 semesters, actually. So we'll still get it back online. A little bit more about Sage. There are actually 2 ways that you can use Sage. One of them is like the regular Python shell. You can try it out in the terminal. There's something called the notebook mode, which gives you a nice web interface access to Sage. So that actually lets you collaborate with other users and share worksheets. So this would be ideal in like a school or a university where you can collaborate with other classmates of yours, or even in research, if you do extensive mathematics work, you can actually use it to collaborate with other people in your team. So, and there's actually something called the Sage Math Cloud coming up, which is like a really set of huge servers out there on the internet for anybody to use. You can actually check it out. It's at cloud.sagemath.org. You can just log in there, sign up for an account, and you can use it. It's exactly same as using the notebook, but they're trying to add a lot of new features to Sage Cloud. Great, yay. Okay. Yay, thank you. Okay. So this might mean that I can really show you a demo, which is really sad. Let me just try, but there's no guarantee, right? So, yep, I already told you about this. I'm a graduate CS student at Amrita University in India. I'm really interested in computer security and Python. That's how I started getting into the cryptography course, and I've actually designed the whole cryptography labs, and I also use it in mathematics courses. I also take part in a few computer security competitions, and I solve most of my crypto challenges using Sage. Yes, and my objective today is to convince you that Sage is really cool and you should use it in all mathematics courses. At least from my experience when I was in school and university, the focus of mathematics courses are usually just on finding the answer. Be given this problem, you have a series of steps you follow and you get the right answer, or you don't get the answer. And I usually didn't get any marks because I don't get the right answer usually. But the most important thing was when I reached university and started exploring mathematics more, I understood that there's just more than just solving the problem and arriving at the right answer. It's how you figure out this is the way to get to the answer. And I found out that when I started using Sage with lots of features that it has, it gives me more time to focus on the Y part rather than finding the X part. As Arthur Benjamin said, mathematics isn't just about finding out X, it's about figuring out Y. And with all the default tools in Sage, I found it really easy to focus more on the problem and think more on it and just use Sage to do all the computations. So this is just an overview of what I hope to cover in this session today. Just how quickly look at overview of Sage and installation. I already gave it, mentioned it already. Quick look at how you can use basic usage, a small contrasting with Python. Finally, I'm covering like 5 or 6 applications of Sage and talk a little bit more about it and how you can probably contribute to Sage too. Right. So Sage is this DPL licensed mathematics software. It's a collection of almost 90 Python libraries and provides you with the IPython interface. You can also use the notebook interface. You can just run notebook in the terminal and you'll get it. You get the power of the IPython shell. Everything fancier comes with it, auto-completion, history, and you also have the Python programming language, which means you can use every other Python library that's actually there. And there's a $home init.sage file, that's like the sage RC, and installing it is actually pretty easy. You just have to download the pre-built binaries from the Sage website. There's also a PPA for Ubuntu, those who are lazy to get it every time like me, I just use the PPA. And in fact, packaging efforts for Debian and Fedora are actually underway right now. Once they're completed, you'll see it in those two and every other distro that depends on them. You can also write Sage scripts and not just the Sage interpreter. You can just use the Sage interpreter, quickly try something out, just like the Python thing. But there's something more about the Sage scripts, that you can actually profile them, and you can even compile the Sage files directly into C and even call C functions directly with the help of Python. Yeah, in fact, Python is actually maintained by the Sage developers right now, so no surprises there. But that makes it much more faster, and you can actually combine those two together. So you can profile your code and see which part of it is actually taking a lot of time, and maybe choose to write or move it to C, or even choose it to compile it using Python. I think that's one of the biggest advantages that I find with Sage, especially in computational intensive applications. Right. So fortunately, I have all the answers to all the questions in this slide. So just before I get into this, I want to tell you that all the answers in this slide were actually created using Sage. I just call a Sage command from this presentation is created in LaTeX, so I just call a Sage command from LaTeX, so it automatically fetches the answer and inserts it there and creates this nice presentation. So I'll actually be talking about Sage Tech later on too. So a few differences with the Python shell. The single caret does the mathematical exponent function, while the double caret does the XOR, and a single slash actually gives you the lowest fraction, and double slash does your regular integer division. Everything else is mostly the same with the Python shell. And you also have a few inbuilt mathematical functions and constants, and you can actually get them with any arbitrary precision you like. You can either specify the precision in digits, or you can actually specify the precision in bits, as I've shown it both there. And yeah, you have all the constants which commonly mathematicians use, pi, e, the golden ratio. The n is actually one that does the numerical approximation. It's just a short name for the big numerical approximation function. You also have sine, cos, and square root that can get it to you in arbitrary precision. Pretty useful, and mostly I found out that the precision is pretty accurate. Right, so that's about it. I think it's just getting the main part where you can all use it. This is just basic algebra that you probably learn in school. You see that most of it is actually there. You don't have to spend time doing this on paper. I spent most of my school trying to factor equations to the power of 4 and 5. Okay, try root 1. Doesn't work. Try root 2. Then go to -1, -2. It's a trial and error thing. So here you just want to quickly factorize it, and so just give a polynomial to it, say factor it, and it gets you all the factors. And you can also iterate over them. It returns it as a list. This is just what gets printed to std out. It's displayed here. I just can't show the demo. I'm really sorry about that. You can also solve polynomial equations for a specific value, like you see right there. The equations are solved. And these are all actually returned as a list, so you can iterate over them, do any fancy modification you want. You can also use the find_root function in specific cases, like this cos equal to sine. You want to find the specific values where those are equivalent. Solve doesn't really do it, but you can also use find_root in those cases. And yes, you can also specify the intervals where you want the results to be returned from. If there are any questions, you can just interrupt me and ask right away. There will also be a question session at the end, but let's just do it in the middle. It makes it easier. Okay. Sorry. Yes, number theory is something that I started using Sage for when I reached the university. When I learned number theory in my bachelor's, I totally hated it because I had no idea what it does. When I got back into masters, I learned number theory again. I used Sage. Found out that number theory is pretty cool, and Sage makes it much more fun to use. I don't have to sit and write a program that iterates over it and determine if a number is prime, or I can efficiently compute the modes, the modulus using mod or even power_mod. They're actually pretty fast. It doesn't look as though this. So we had a contest like a week ago. I could go up to power of nearly 10th power of a 6-digit, 8-digit number mod, a 4-digit number. I got the result in like 2 seconds. So it's really, really fast, unlike what why the code I write in Python is really slow, but this is highly optimized by them, so you don't have to work on that. You get the results really fast. You can quickly generate primes in any particular range. You can check if a number is a prime pretty fast, and next prime, previous prime, finding out the factorial of a number, PCD, LCM, it's all there. I mean, I still don't know how to do some of these on paper, like GCD and LCM. I'm still not sure. So I'm so used to Sage, I just rely on it to take care of all of that. So you see here that it provides you with a lot of building blocks that you can use to further your whatever you're working on right now, especially in schools. Lots of people spend time doing all this. You don't need to know how to do GCD on, you don't need to really do GCD on paper, so as long as you know how to do it. You just use this and get down to what's the most important bit. So did you see that it's mostly the theme throughout my presentation I'm just showing you. It's really easy to use, really easy to get started too. In calculus is some ways where I really wish I already knew Sage. I just started using it very recently to do differential and integrals. I used to struggle to do almost every kind of differential and integral. I found out that just give it a function to it, it gets you the value, gets you the answer. So it makes it much more easier, especially when you're doing fluid mechanics or something like that, where you really need to use all these or any others. There's a lot of applications for calculus and mechanics. I'm not very familiar with it, but it makes it so much more easier to use. So you just don't need to spend time finding out the result, just feed it to Sage, it gets you the answer. Like, actually, I don't know, it's pretty good. And also, in fact, you also have support for partial differential equations, and you can even solve differential equations. I didn't add them because I don't know them, so I was not, but I'm sure if you already know about it, it's pretty easy to get started with it in Sage. They actually have a guide for those who already know mathematics very well to get started with Sage. I'll just give you the link later on in the presentation. So, yeah, okay. So plotting graphs is something where I don't know, lots of people do it. I play around with this quite a bit because it's a lot of fun. You can actually plot 2D and 3D graphs. I wanted to show a demo of 3D, but yeah, I guess it's not going to happen. I don't want to mess with this setup anymore. Let's just go as it goes. So, maybe at the end. Yeah, maybe at the end. Yeah, sounds nice. So this plot is actually plotted using the the Sage plugin for tech. I just say plot this function. The circle, the function is actually plotted as a circle centered at 0, 0 of radius 4. So you can actually do a lot of things with this. You can adjust the size, change the color. You can even plot multiple functions in a graph like I've done here. This is the plot of sine and cos together. You can set the colors for them. You can set the scale. You can set the range of values you need it in it. So, graph plotting is something I used to do on a graph paper back at school and even in the university. So when you have this, it makes it much more easier. You don't have to spend time. And I'm very bad at drawing. So I just can never get the graph to look really good. But you have text here, you have Sage here. It makes it look extremely beautiful. You can even add another function to it. You can add as many functions as you want. So as long as you can identify them yourself, and the graph will still look really good. Yep, I actually have a 3D plot here. It doesn't look as impressive as it actually does in 3D. So this is like the 2D version of the 3D thing. So in the 3D version of it, you can actually interact with it, rotate it around, see it from any angle you want. It's actually rendered using JMOL, that's a Java molecular manipulation library. I don't know where they chose that, but it works fine. It looks really nice. There's a lot of things that you can play around with 3D in this. I'll see if we can show a demo at the end. So that's mostly about graphs that I had to say. Matrix algebra is another place where I've been using Sage for quite some time now. My last semester courses mostly involve a lot of matrices. Even now I'm learning linear algebra where I use this. In my bachelor's, I actually wrote a program to do the matrix multiplication. It took a long time. I spent like a day debugging it. I had no clue where it was going wrong. When I found out that Sage does it automatically, I just stuck to all those programs and started using it. So this Sage actually lets you treat matrices as regular integers or floating point. So you can do all the operations that you want, inverse it, add it, subtract it, multiply it any way you want, exponent it. You also have the other functions like defining a determinant of a Sage, and you can check properties of a matrix as well, such as whether the matrix is singular, is it a symmetric matrix, is it skew symmetric, can you invert it, And it's very easy to find out what is supported because IPython has this auto completion thing, so I find it really useful. I found most of these by just using the autocomplete. I just didn't read any of the tutorials. But they have a really good tutorial on matrices, yeah. So you see matrix, I'm working with matrices is actually very, very easy with this. I don't think you can get any simpler than this. Disclaimer, I haven't used any of the other mathematics algebra tools, so if you do know it's easier in that, please do let me know, I'll be happy to correct it. This is the first thing I found, I don't think I want to go back to anything else though. Right. Oh, so I guess, sure, I'm a little slow anyway. So LaTeX is something where lots of people, especially mathematicians, would like Sage to help out. And in fact, you can actually generate the LaTeX representation of any object that you want. So just feed a variable to LaTeX of that variable and you'll actually get the LaTeX representation of it. And Sage Tech is the one that I use to create most of this presentation along with Beamer. It lets me call any Sage command I want and even plot functions as I would like. All the results in the earlier slides are actually results of the Sage command, and the graphs are plotted actually using Sage plot. The presentation slide is there on my GitHub, so you can always go check out a lot of Sage Tech examples there. I found the documentation on Sage Tech wasn't very good on the website, so I just created these slides. So anybody who has some difficulty in Sage Tech, you can always check my slides out. You also can embed Sage code in the middle of your tech presentation, and you can choose if you want to display it. Like say I do Sage block and within it I declare a few functions and a few variables. All those can be declared in a nice mathematical formatting. Sage takes care of all that and looks really nice in the LaTeX document. If you don't want to display it, just say Sage silent and you can access those variables that you have declared in the block anywhere in the Sage, anywhere in the LaTeX document. So that makes it easier. It's kind of like Sage programming within LaTeX. I found a lot of fun. So I'm sure a lot of mathematicians actually use LaTeX for their typesetting work, and now you can also use Sage to fetch all your results from Sage and directly add it in there. It makes it much more easier. Yeah, okay, yeah, I think. Yep, so that's about it. I know we rushed through it, so I'll try give a demo if I can once I finish the rest of the slides as well. So these are the things that I never talked about, how you do this in Sage. There's a lot of intricacies if you get into the Sage internals, like how does it actually interface with all the other mathematical systems like GP or Singular or Maxima. In fact, for a few functions, depending on the kind of input that it gets, it actually chooses which library to actually use underlying. So say for smaller input, it might probably use GP, but when it goes to bigger inputs, it chooses something that's a little bit more optimal for that size. So Sage does all the decision making for you in those and tries to find the optimum way of finding the answer. And you can of course override it and interact with each of these libraries directly. So it gives you all the bells and whistles. Yes. Yes, yes. Right. Oh, okay. Oh, right. I didn't list it here, but yes, it is actually there. It actually gets PyCrypto's help to do all the crypto work. So you have all the modules that are defined in PyCrypto which support RSA, DSA, AES, and DES. I've used it mostly for the public key, mostly RSA actually, but most of the time I'm not required to use the crypto as such. Most of the time I find out that I can implement the primitives myself. Or in most cases, I had to implement it myself because it's a very specific case in particular challenges. But those libraries are always there. It's PyCrypto. I think it is I think it's PyCrypto PP. I'm not so sure. And of course, you can add your own crypto libraries to it, so you can choose a better one if it exists. Yeah, but I should have listed it there. Sorry about that. So linear algebra is something that I'm exploring right now. I have a course on linear algebra this semester. I'm finding it really useful to learn Sage because I've never learned linear algebra before, and I'm finding that focusing on Sage lets me focus more on what's important and let all Sage do all the computation work. Makes it really easy for me. And of course, there's advanced applications of almost everything that I spoke about right now. So I'll just point to a few tutorials about it and see if we can get to a demos. I think we'll do it. Okay.
screen session. So if you.
Oh, this is okay. Ah, great, fantastic. Okay, that was fast. Right, so, yep, 3D plots, 3D plots. Right, good. Oh, man, this is going to. Yeah, so this is the plot 3D I was talking about. You can actually interact with it. Okay, I'm sorry. Right, so you can actually see that you can interact with it, just turn it around any way you want. Let's 3D interact with it, even zoom in and zoom out. You can actually give colors to it. I just didn't give the colors right here to get you this nice rainbow thing that I have. Yes.
I have a question.
Yes.
So, how is Sage in comparison to?
Yes, yes. Disclaimer, I haven't used any others. So, yes. Oh, no, that's okay. I could repeat the question. It's okay.
So, how is Sage in comparison to other frameworks like MATLAB or like Maple? And why is it not as popular as them?
Okay, so the question was how is Sage compared to other mathematical algebra tools and why is it not as popular as them? So I haven't used any of the others. I did say that at the start, I just say it again. I haven't used any of the others because the first thing I found was Sage. A friend of mine said, hey, I use Sage for crypto and it was very nice. I was like, okay, let's check out Sage. And then I found out that it's Python. I didn't want to try anything else after that. You know. So as to why it's not popular as the others, I have no idea. You know, because I think one of the biggest reasons is nobody knows Sage. Even I didn't know Sage when I started using it. It's because somebody else told me about Sage that I got to know about Sage. My mathematics professors don't know about Sage. Every time they ask us to go back to MATLAB, okay, this is the function in MATLAB, if you do this, you get it. I'm saying, okay, why don't you say something that's open source? No. So, I mean, MATLAB is like really expensive. I don't think anybody ever gets their hands on MATLAB. And it's the reason why my professor keeps saying MATLAB, MATLAB. Nobody ever uses it at all. Yeah, yes, please.
But I mean, like, is it how developed it is? So how developed it is in terms of optimization problems. So if you want to like, I don't know, like use it in finance, you would have to do like portfolio optimization, or does that have libraries for that? Or
so I had actually mentioned that earlier. So this is actually, Sage actually just finally a Python interpreter. So that can get pretty slow. So you can actually profile your Sage code and see where the problem exactly is, and you can maybe move that over to C. That makes it really faster, or even C++. And you can make a module out of it and directly call it. So that's the best optimization that you can do, take it down to C. But otherwise, most of the functions that are already there in Sage are pretty optimal. In fact, for some of the functions, it uses multiple libraries depending on the input range. So if the input's like really small, it will probably choose GP, and if it's really large, it might avoid GP and choose something else, like singular or maxima. I don't remember a function, but there's definitely a function like that that makes the decision based on the input. So, and you can also compile it into using Python. So there you get the C code directly. That makes it even more faster. 10 minutes? Okay. So this is a 3D plot. There's a, I think we'll just go to questions. Does anybody want to see a demo? If not, I think there are a few questions. Or yeah, just go ahead.
Well, thanks for a great talk. Are you aware of any Sage user groups or Sage conferences? How do you, or how do Sage organize itself? Do they have conferences?
Okay, I don't know if, I think there was a conference like few years ago. That was even before I started using Sage. I think they spoke at one conference in Europe. I'm not really sure if they meet regularly, but there's a very active IRC channel and a mailing list. And yes, I'm actually subscribed there. They have a lot of discussion mostly related to development, or I think I picked the development one and not the user one, I'm not sure. But they have a pretty good IRC channel. Everything is there on their website. Should probably show that. Oh, okay. I haven't really explored the community much a lot actually, so yeah. Should probably ask him. So thanks. Oh, right there.
So my question is about the notebook, and I was wondering if it is as advanced as the command line, and if there is any downside of using the notebook, like performance issues or maybe missing features.
So I think in the notebook you actually get a terminal. With the notebook you can also get a terminal, but you can actually create a workbook or a worksheet. That's how it works in notebook. One of the biggest problems why I haven't used notebook is because setting up a notebook server to collaborate with a lot of people is kind of hard. So if you're just a single user who's going to use notebook, that's really easy, but setting up a thing is hard. I mean, it's just not documented anywhere as such. That's one of their contribution opportunities actually. Make it easier to set up a notebook server. But I think you're probably better off using Sage Math Cloud, because that's going to be the future of Sage over the notebook mode. And Cloud's already there online. You can just use it, collaborate it with any other user in there. So I would actually recommend Cloud over the notebook mode. Just right there.
Is there a compatibility between Sage and MATLAB or some other software?
Right.
I was wondering. Okay, is there a compatibility between Maple, MATLAB, and Sage? I mean, if I have a library, I have written for MATLAB. Can I somehow use it for Sage?
Right. So the question was, is Sage compatible with the other mathematical software like MATLAB or Maple? I'm not very sure the extent of it because I don't have access to any of those. But from what I've read in the developer documentation, making the interface to the other libraries is one of the biggest to-do tasks right now. I think they proposed it for GSOC last year and maybe even the year before that. But I'm not sure, I don't think anybody worked on it though. So if there's somebody who is familiar with it, I think they will actually use some help in those areas. But I'm not familiar with them as such, so I don't know how good it is.
Yeah, all right. And the other thing, could you show us please the notebook interface, the web-based interface?
Okay.
Whether you could show us that.
Oh, show it? Okay.
Yes, I would be interested to see.
There's a couple of worksheets on my laptop there already if you want to use those.
Okay, sure. Right. Just I think you ran out of battery. It just turned off.
Run out of battery.
Okay.
No.
That's fine.
But it's really easy to get it started. Just run the terminal, type in notebook function, it gets started up. It runs a twisted server at the back and prints out which server you can connect it to. So just open a browser and you can just type in the URL and you'll get it. Pretty easy to get started. I think someone at the back had a question. Yes. Damn, this has been a disaster. Right there.
I don't really have a question, only a comment on the price of MATLAB and Mathematica. I don't want to get into any trouble, so I can't say anything specific, but there are ways to get them for free.
Oh, okay. Okay. That's news. I just didn't know that. I mean, I told you that. I just learned about Sage, started using it. I found out that's really cool, so I just stuck to it. So, yeah. Yes.
Are there any symbolic features for doing things like solving or simplifying equations?
No, I didn't get you, sorry.
Features for symbolic work, like solving equations or simplifying them.
Oh, okay. That was actually there in this. There was a slide that dealt with solving polynomial equations. I don't know if so I don't know how many variables. There is a way to solve polynomial equations. I've definitely done it myself, but I don't know how many variables it extends to or how complex it can go. For really simple ones that at least works in what I've seen in my curriculum, it works fine. But for real actual things that you see in real life, I don't know how good it is as such. I've not done it before, but I'm pretty sure it kind of works. At least what's similar to what I've done. So, any other questions?
One more.
Any other questions? We're almost out of time. No, I guess not. Okay. I just quickly run through. Do I have time?
2 minutes.
2. Okay, great. So I just want to talk a little bit about how you can actually contribute to Sage. One of the best things that you can do was slightly raised by somebody who said that not many people know about Sage. So you go talk to people, tell them about Sage, especially people who already know Python, because they'll find it very easy to use. And you can actually extend it with a lot of Python libraries, so that makes it a lot easier to use and a lot of fun. But more importantly, integration with the big M's is a big deal right now. So if you're interested in helping with that, if you're familiar with them, you can help us out in that probably. But the more important thing is there's a lot of areas within mathematics that are not completely supported in Sage or not at all. If you're into mathematics and you know those areas very well, I actually wanted to show it to you. But so if you're really interested in any of those, you can probably contact the community about it and help out in that. That's mostly about what you can do in Sage. That's the most priority thing right now. And of course, you can actually, if you teach courses in mathematics or you know somebody who teaches courses in mathematics, encourage them to use Sage Math Cloud. The UCLA's calculus class actually uses Sage Math Cloud right now. So you can actually get a lot more people to use Sage and spread it around. Right. Thank you very much for, I know it was